Welcome to your first physics lab, and today's lab we're going to be talking about measurements. So the objectives for this lab are going to be to learn to use our measurement tools. We're going to be using 4 tools. We're going to use a mass balance, a caliper, meter stick, and stopwatch. If you haven't already done so, I would go ahead and watch the tutorial for the balance and the calipers. They're posted on YouTube. And then the second thing we're going to do is talk about analyzing errors. Now, as we've talked about, every measurement you make is going to have an uncertainty. So that's what we're going to be doing in this. This lab has 4 parts. Now, the order in which you do them isn't important, which isn't entirely true because you need to measure the mass and the volume before you find the density. But regardless, you can measure time while somebody else is measuring the length of the block. Now, we're going to measure length using 2 tools. One is going to be the meter stick, and the other is the caliper. And you are going to use that meter stick to a more precise version. It is a tool of science now. So to get us started, here's a video of using the meter stick. So in this lab, we're going to calculate the volume of this block. So when we're talking about volume, we're going to talk about length, width, and height multiplied together. And to do this, we're going to use a meter stick, right here, and calipers. Now, a couple notes about using the meter stick. First thing I want you to notice is the end of these meter sticks that look like they've been chewed, dropped, kicked. Engineering students have sword fought with them. You know, who knows what happens? So the bottom line is never measure from the end of a meter stick. Second thing you might be thinking is, oh, I'll just set it up at 10 because that's easy. But when you do that, you haven't set it exactly at 10. Here, I'll do this. Look, I set it right at 10. But if you get really, really close, you'll see that it's just a hair over, or under. It's not 10. So what you do, every time you take a measurement, take the block, just plop it down. Measure this side, again, straight on. So this looks to be about 15.73. And again, make sure that you go 1 over, and then you'll measure the other side of the block. Straight on. And again, that looks like 23.1, I'm going to call it 23.14 centimeters. So 2 important things. A, you're always going to measure in between the lines to the nearest tenth of what you can measure. Your eyes are going to hurt after this lab. That's normal. You'll get used to it. The second thing to note, always record the raw data. So in this case, it would be that 15.73 centimeters. And 23.14 centimeters. So this is the only lab where you are going to record your data on the data sheet. It's the sheet attached, you'll find it in the lab, and it's got little lines with everything specified. So you'll record your raw data on this. Remember that the last column, you're going to get a plus minus, and we'll talk about that in a second. You will repeat your measurements with the calipers, again, 3 measurements on each side, and then we're going to talk about the error analysis. And since you have 3 measurements, your uncertainty is going to be the max deviation from the average. Now remember that you will always report your answers as some average plus or minus some uncertainty. For part B of this experiment, we're going to calculate density. So what I want you to do, I want you to watch the video for the mass balance. That way we can talk about how to read it. Again, we always read in between the lines. Then we're going to calculate volume, and since volume is length times width times height, you'll see that these quantities are multiplied. So when we're propagating error, if you think back to that handout, we add the percent uncertainties. So you'll say, oh look, length is 3% off, width is 3% off, height is 4% off. So your error percent would be 3 plus 3 plus 4, which would equal 10%, which is a little high for this lab, but that's all right. Then you're going to calculate density, which is mass, over volume. And again, since you're dividing, you're still going to add your percent uncertainties. For part C, we're going to be dropping a marble. And we're going to drop this marble about 10 times. But so you don't drop the ball with error, see what I did there? That's a horrible physics joke, but let's continue on. Since your n is greater than or equal to 10, our uncertainty is going to be standard deviation. So please refresh the handout. So you're going to get your time, you're going to get your uncertainty in that measurement, but how do you find the actual value? Well, your marble's going to go, it's going to fall 2 meters. You know what's accelerating it. Constant acceleration problems, just talked about this in class. So I want you to devise a formula and figure out what the actual time should be. And then you can compare it to what you got experimentally. And to show us a little more about this, here's Dr. Fox-Linton.
I'm going to be timing how long it takes this ball bearing to hit the ground to fall 2 meters. So the idea is it stops from the bottom of the ball bearing hits the ground, so I want to start when the bottom is 2 meters up. And I'm going to be starting the timer myself to cut down the reaction time so I don't have to worry about talking to anyone. So I'm just going to hit start, let go at the same time hopefully, and then when I hear it hit I can hit the stop. So here we go.
So part D, the final part of your lab, you're going to be using a pendulum. You're also going to be making a graph using graphical analysis, which there's also a tutorial video for. So again, watch tutorials. They will help you, and since we're going to be doing the same type of stuff, it's nice to get some refreshment, it's nice to get refreshment as well, but it's nice to get refreshers on these things. So what we're working on here is a simple pendulum, and we're going to measure the period of the pendulum, how long it takes to swing one full swing. And we're going to base this off of its length. That's what we're going to graph. So what we're looking at when we're talking about length is the length from right here where this pendulum touches the metal, all the way down, well, where would it measure to? If you measure to the top, your pendulum's too short. Measure to the bottom, your pendulum's too long. So if you measure to the center, that's just right. Now the center of this ball is 2.54 centimeters, so it's 2.54 centimeters divided by 2, half an inch, but refrain from that in this class. And then what we're going to do is we're going to swing it, and we're going to use the small angle approximation, so it's 5 degrees, which is barely any swing. So you let it go. And it doesn't matter, you don't have to start right when it goes. And when it hits the edge, you'll hit start. And it's going, and you're going to count 25 times. So through the magic of time-lapse video, and 25. We will stop it, and you will record. Now, since it's a timing measurement, when is most of your error going to come from? Okay, you should be thinking about this right now as you're doing it. It should come from whenever you hit the button. So by timing it 25 swings back and forth, you'll minimize that timing error. So when you're doing this lab, again, remember, multiple swings to minimize your timing error. And then when you're going to graph it, we'll have some, well, let's talk about this for a second. If we compare this, it's going to be a linear equation. We want a straight line. So the equation for a line is y equals mx plus b, which if we start matching things up, we can see that, oh, look, period matches with y. This whole thing matches m, and this is x. Now, graphical analysis doesn't like powers to the 1/2, so what you have to do is you actually have to calculate it to the 1/2 and then plug it in. And in this case, b is just equal to 0. So when you graph this, you will get a straight line, noticing the y-axis will be your period, and the x-axis will be length over 1/2. And when you graph this, you will compare the slope from the graph with your error bounds, again, check the tutorial for graphical analysis, with what the slope should be, and make some comments on this. Are they the same? Are they different? Why would they be different? And that wraps up your first lab.